Hi class 10. So it's been a while since the holidays had ended. And still, this is the first video lesson you'll be learning after your industries chapter. And I already gave you a little bit of revision related to the industries chapter because what you learned in the industries chapter, especially what you learned about the iron and steel industry, it is highly related to this chapter. So chapter will be starting today will be minerals. And when you look into this picture, you can see that minerals are of different shapes, different structure. It has different modes of formation. But to get an idea of the four important minerals that we'll be learning, we have to first understand what is a mineral and what is a rock, what is an ore. All these terms which we would have heard many times, but still we don't clearly kind of know the difference, because only when we know the clear difference between these three, or between the four or five, if you add crystals and gemstones along with it, only then we'll be able to understand the chapter in detail. We're going to learn about four major minerals which are abundantly found in our country. But to learn that in detail, we must know what is mineral, how is it formed, and why is it classified, and how does it become economically useful and stuff like that. Okay, so in the syllabus, there has been slight changes that has been made, and for your class 10, the changes that has been made is very little. So I'll make sure that I'll uh, let you know what are the changes that has been made in the next Zoom session. But as of now, the chapters 3, 4, 5, 6, 7, 8 till 7 has not been completed. So we'll be starting off with 8 today, and 8 includes mineral and energy resources. We'll just be looking into mineral in this video lesson. Today's topics would be iron ore, manganese, copper, and bauxite. So that is what I told. We must know what is ore, because in these four terms, two terms are ores. Iron ore is an ore, and bauxite is also an ore. There are a lot of names given for iron ores, which is also we'll be learning about it, like hematite and magnetite and limonite, but that's not given. Same way, manganese and copper are actually not ores, but they are actually elements, or you can also call them metals. And these two are very important transition metals, and these two are also taken out from ores. So we should know the metal which is being taken out, or the main metal which is being taken out by from these ores, and for iron ore and bauxite. At the same time, we should know what is the ore which is helping us to take out manganese and copper. So that's why knowing the basics is very important. We'll be learning about the uses, what is it used for, and the distribution, how it is distributed in our country. On this side of the syllabus, transport, waste management, industries has been completed. So that, other than that, agriculture and the second half of energy resources will be completed in the coming days. So to start off with, there's a small video which is very descriptive, and it gives you a very good idea of what minerals are, what rocks are, and what ores are. Then I'll also explain related to the video. Check it out.
As you may already know, the Earth's crust is made of rocks. If you look closely at a rock, you will see that there are many different bits. Some bits are dull, whereas other bits are rather shiny. The main idea here is that all these components occur naturally. In other words, they are not made in a factory or by a human being. A naturally occurring element or compound is known as a mineral. Ore is simply a rock containing a high percentage of a certain mineral. For example, hematite contains a high percentage of iron. The extraction of iron from hematite is done in a blast furnace. Malachite contains a high percentage of copper. Cinnabar contains a high percentage of mercury. We can think about an ore a bit like a chocolate chip cookie. We really want the chocolate. If there are more chocolate chips in the cookie, then the extraction process would be more economically beneficial. As more minerals, in this case, the chocolate can be obtained. If there are fewer chocolate chips, then the extraction process may not be as economically beneficial. For the most part, the minerals are oxides, carbonates, or sulfides of the metal of interest. Some ores of nonmetals include quartz, which contain a high percentage of silicon in the form of silicon dioxide. Limestone is also an ore. Can you remember what is found in a high percentage in limestone? Pause, think, and continue when ready. The answer is calcium carbonate. Limestone contains a high percentage of calcium, but calcium exists as calcium carbonate. The iron in hematite is mostly iron 3 oxide. The copper in malachite is mostly copper 2 carbonate. The mercury in cinnabar is primarily found as mercury 2 sulfide. The extraction process for each ore can vary, but the key idea here is that the mineral must be present in a high enough percentage, or else the process would not be very economically beneficial. Now,
Okay. So that video gave an understanding of minerals and ores and a little more basics about rocks. So the basic understanding is that in a mineral or in a rock, if there's high percentage of one mineral, it can be one element or a combination of one or two elements, then you would want to remove it out of that combination minerals, and you can take out what is useful and throw away what is not useful. So if you take out something from a mineral or from a rock, only if it's present at a huge amount, then taking out will be economically beneficial. Otherwise, you're wasting so much energy and time to take out something which is very little. So we'll again go through and have a wrap up of what is a rock, what is a mineral. I hope this will give you a better understanding. So in simple words, minerals are just inorganic substances. Organic substances are something which is made up of carbon, cardboard, wood, paper. All these are organic substances. Leaves. So these all get burnt and can get decomposed. But these are inorganic substances which are naturally occurring, formed when one element. Please take note of this: one element or more than one element. It can be one element also. For example, graphite. You take graphite, it is considered as a mineral, but it just has carbon. It doesn't have anything else. So even if it's one element, it can be considered as a mineral, or if it's more than one element which combines together, then also it can be considered as a mineral. So formed when one element or more than one element found on Earth. Obviously, if it's found on Earth, it's also seen in the periodic table. When they combine together, it's called a mineral. Minerals have tiny amounts of trace elements as well. So you have a major amount of two elements or one element, and there will be minute amounts of maybe less than 1% or 0.001% of other elements, which can be considered as negligible or can be considered as invalid, but still that is what will give color to the mineral. So minerals have a chemical name and a commercial name. For example, you saw the example of quartz. You'll be seeing a picture of it in a few moments. So quartz is silica and oxygen. So silicon dioxide is the chemical name, but at the same time the commercial name of quartz would be quartz. That's how it's sold. So that is quartz. Okay. So that's the same example that's going to be written here. Example, silica, which is also found in the periodic table or found on Earth, and oxygen, which is also found on Earth and on the periodic table. These are the major elements. When they combine together, they form SiO2, which is silicon dioxide, which is the chemical name, or quartz, which is the commercial name. They also have trace amounts, which means tiny amounts of titanium, iron, manganese. All these will give a pink color to the quartz. So remember, Si and O will always be the same. the color of quartz will keep on changing depending upon the trace elements. Just because you have a blue color quartz or a yellow color quartz or a pure white color quartz, there are so many colors of quartz, doesn't mean that silicon oxide is changing. Silicon oxide still remain the same. The only thing that changes is the trace elements. So any quartz, any color, it is always made up of SiO2. So that is a mineral. I hope all of you understood what is a mineral. So what about rocks? We understood what is a mineral. Then what about rocks? Minerals combine together. So you have quartz, which you found a huge pink quartz picture in the last slide. But in every place, do we see in minerals in that huge structure? It's very rare to find minerals in a large scale structure. We find minerals in small bits and pieces because many minerals combine together and form rocks. And rocks is what we see more commonly. And inside rocks, minerals are actually very tiny. A combination of many minerals in a varied proportion. For example, there is a rock with mineral A, B, C, D, E. A is of 25%, B is of 20%, C is of 10%, D is of 5%, and the remaining percentage is E. So there's a combination of 5 minerals, and all those minerals are in different proportions, and together they form a combination of minerals, which is rock. So the example we'll have here is granite. Granite is a combination of many minerals. Among them, the major ones are quartz, then you have feldspar, then you have biotite, which is a black thin mineral, then you have mica, or it's also called muscovite. So you don't have to remember the names of all these. This is just for you to understand the basic concept of what is a rock. So you have quartz, you have mica, you have biotite, you have feldspar. When you combine together with, maybe there are many other minerals also, but these are the major ones. Like if you take 100%, these four minerals will take away 95% of all the 100, and the remaining 5 would be other tiny minerals, which I have not mentioned here. But these are the major minerals, and together they will form or give you a granite. So just like quartz, granite also has hundreds of variations. There's pink granite, there's green color granite. So it all depends upon which mineral among all the 4 or all the 5 or all the 6 is dominating. For example, let us imagine that this granite pink color is dominating, or let us imagine that in this granite black color is dominating. So it will obviously be called biotite granite because biotite is dominating, biotite is more. So every rock has hundreds of variations and so much variations depending upon where it is formed, depending upon the proportion of one mineral. If one mineral is more than the other, a little bit more than the other, it will automatically become named after that mineral. Okay, so you know what is a mineral, you know what is a rock. Moving into the last one, and the most important one related to this chapter, ores. But sometimes a rock can have one mineral in very high proportion. It's not about the previous one which I was talking about. Imagine there's one rock, and in that rock, 80% is just one mineral, and the remaining 20% forms all the other minerals together. That's what's happening here. But sometimes a rock can have one mineral in very, very, very high proportion, well, all the other minerals put together, less proportion. For example, there's 5 minerals. Mineral A is 80% or 75%, and B, C, D, E together forms only 15 or 20%. Then what you can do is you can try to remove that 80% mineral out of it. So in this case, it is called an ore. So only when one mineral is dominating extremely in such a way that it can be extracted out of it, then it is called an ore. Okay, these ores are mostly used to extract that one mineral which is in high proportion. Mostly the minerals that is extracted would be metals. So you already know that minerals is one element or a combination of one or two elements, and the elements are found in the periodic table. And the elements can be anything. It can be metals, it can be transition metals, it can be non-metals, it can be anything. But mostly, why would you want to put so much effort and money and energy to take something out if it is not going to give you any economic value? If it's going to give you some economic value, you would put so much effort and machinery and energy, and you'll open up industries to crack open a rock and grind it and powder it and in such a way that you would remove the mineral out of it. So you do it only if it's going to make you or give you some money or make some economical benefits. And mostly the mineral which is going to give economical benefits are those which are metals. So most of the minerals that are extracted from ores are actually metals. So it is mostly misguided that metalliferous minerals are ores, but it's not always that case. For example, from quartz you can take out silica because quartz is silicon dioxide, and silica is actually not a metal, but still you can take it out. But nobody would do that because silica is not that expensive. But for a person who wants to take out iron from an iron ore, he would definitely do that because iron is more expensive. So only according to economical benefits, the mineral is extracted out of the ore. Ores also have a chemical name and a commercial name, just like minerals. For example, magnetite is iron oxide, which means iron and oxygen, along with other elements in small amounts. So here you have a picture of magnetite. It's very black, shiny in color, really hard and heavy. It's made up of more than 70% iron, which means this is it can be considered a rock also, but since it has a dominant amount of one mineral, it can be called an ore. So magnetite is an ore. So this piece of rock which you see in the picture has 70% iron. But what we should do, we should remove that 30% iron, sorry, 30% unwanted stuff from this rock so that it can become 100% iron. It can become something like this. It can become an iron bar which is made up of 100% of iron. So for that, the extraction process starts. So not just magnetite, there are so many other iron ores. This is a dominant iron ore which has high iron percentage. So usually you would choose a ore which has more percentage of the metal or mineral. So the chemical name is magnetite. Sorry, the chemical name is iron oxide, while the commercial name is magnetite. Since iron is present in a high percentage, this can be considered as an ore to extract the metal iron. Some ores other than magnetite, there are many other ores also, have beautiful color and a beautiful appearance and a beautiful formation. That's why they are used as gemstones. Magnetite is not used as gemstones, but some other ores which you will be learning in the upcoming slides, you can see that they're so beautiful in such a way that they are even used for ornamentation and as gemstones. So we'll be learning about four main minerals, and you need to know the ores related to those minerals. So if you hadn't had this basic understanding of what is a mineral, what is an ore, what is a rock, it would have been really difficult to start off with. Actually, this is supposed to be the first slide, but now you will know that because you got a basic understanding of the previous three terms, you'll be able to relate and understand with it in an easier way. So you'll be learning about iron ores. So now you know that iron ores mean a rock which has high percentage of iron, and something which is not needed is also there. From iron ores like magnetite or hematite, we are trying to take out the metal iron. Number two, the term given in your book, number two is manganese. But manganese is not an ore. Manganese is a metal which should be taken out, or it's a transition metal which should be taken out from an ore. So in your book there's a mistake. The four terms which are given, not all four are ores, not all four are metals, and not all four are minerals also. One, the name is given an ore, one name is given for a metal, one name is given, for example, the third one it is given bauxite. And bauxite is actually the commercial name of an aluminium ore. But for iron ore, they've given the chemical name like iron oxide. So to have a basic understanding of what is a mineral, what is an ore, and what is a rock really helps you to understand. Okay, when they mean iron ore, it is a rock or a structure which has high percentage of iron, and from that we are going to take out iron. Then manganese is what is going to be taken out from what? From what is it going to be taken out? It is going to be taken out from a manganese ore. Then you will be learning about bauxite, which is already an ore, name of an ore. So what is going to be taken out of bauxite? Aluminium is going to be taken out of bauxite. And the last one is copper, which is the name of metal. So that should be taken out of an ore, which is malachite, chalcopyrite. There are so many copper ores also. So you'll be learning about iron, you'll be learning about manganese, you'll be learning about bauxite, but bauxite is an ore, so you'll be learning about aluminium. So iron, manganese, aluminium, and the last one, copper. These are the four important metalliferous minerals or metallic minerals that you will be learning in this chapter: iron, manganese, aluminium, and copper. So when you learn about each mineral or each metallic mineral, just focus these points, which will help you to learn it in an easier way. Don't learn in paragraphs, it would be difficult. Just focus on these points alone. Ore and composition. What is the ore? What is the composition? What is it extracted from? Okay, we're going to learn about iron, we're going to learn about manganese, about copper. What is it extracted from? Where is it taken from? And what is it made up of? Copper is made up of Cu or copper, but before it is in an ore. What is an ore made up of? That is what is based on the first point. Second point is characteristics. What is it known for, or what is it famous for, and things like that. The third point and the fourth point is what is based on your syllabus, which is distribution and uses. Distribution is where is it found in our country in abundance. So please make sure in distribution you're not actually needed to learn about where is it distributed in the whole world. Just distribution in India, the 2-3 important places where it is distributed in abundance, and uses what we can do with it. So we'll start off with iron. So before we move into each and every metal, I'll be starting off with pictures which is relatable to you. So you'll be thinking about what has iron to do with my life? What has manganese to do with my life? What has copper to do with my life? What has bauxite and ore, which I've never even seen, to do with my life? But really, these four ores and metals are highly involved in your life. Maybe you're not noticing it. So I'll start off each and every metal with pictures that you can relate to, that you really have seen, or things that you have really seen or use every single day, not knowing that our country is using these ores and metals for making our everyday life better. So the next time you be using all these things, you can remember that it's because our country is actually blessed in having these minerals in high abundance. That is why we are able to use it. Okay. Iron in our everyday life, you would have seen this. This is not iron, this is actually steel. So in the previous chapter we learned that iron is actually manufactured and transformed into steel so that it doesn't corrode, and it is more stronger. It can be easily changed its shape and structure and flattened and strengthened. So these are steel structures or steel vessels. We use that every day. So iron, you use it in your everyday life from steel. Or a hot iron press to press your clothes or to iron your clothes. The bottom part of an iron is made up of a mixture of iron and steel or tin or zinc. There may be a mixture of other elements also, but it is majorly composed of iron. That also you use every day at home. Then pipes, every single connection of plumbing and water work at home would have been done with steel pipes, or there would have been iron rods on which your home is actually stable. So let's not think that these are things which are not at all connected to our life. All these four important metals you're going to learn is highly involved in your life. The number first one, iron, this is how it's relatable to you. Okay, what are the major iron ores then? So you know that the final products of iron, how it's relatable to your life. So where does it start? That is the ending point of iron in our lives. Where does it start? Where is the starting point? The starting point is from the ores. So these are the ores, major ores. There are many ores. These are the major ores. You have magnetite, which is an iron oxide. So usually ores combine a metal with some other element in the uh, periodic table. So this is iron combining with oxygen. So in this ore you get 70 to 80% of iron, and it is magnetic in nature. It is shiny black in color. Then you have hematite, which is 70 to 75%. It gives pure iron. This is also a variation of iron oxide. Is also iron combining with oxygen. It is reddish black in color. This is not magnetic. Magnetite is magnetic. Third is limonite, which is 40 to 55%. It's yellowish brown in color. But look at this. This is not iron combining with oxygen. It is combining with water. H2O. Can you see one H and two oxygens? So this is iron combining with H2O. Maybe at high pressure, at high temperature under the surface of the earth, when oxygen, two oxygen molecules, one hydrogen molecule and iron combine together, you get something like this. It is easily breakable. It is not as hard as magnetite or hematite. So that's the characteristics. And the last one is siderite, which is, when you look at these four, the comparatively the lowest quality, but still it can be used as an iron ore. It is iron carbonate where iron combines with carbon. It is also used as a brown pigment because it has a very strong brownish red color. So these are the major iron ores. You really should know the names of the major iron ores and the chemical composition, and also one or two iron ores which gives the maximum percentage of iron should be known. What are the characteristics of iron? I think most of the characteristics you can guess. Iron is produced in a blast furnace, which we learned in the previous chapter, at about 2000 degrees centigrade by the reduction of hematite or magnetite with carbon. Iron is very ductile, gray, relatively a soft metal, but it is relatively a soft metal only after it has been transformed to steel, or only after it has been molded or shaped into steel. When it is as pure iron, it is actually a hard metal. So don't be misunderstood. Only when it is converted into steel it becomes a soft metal, but otherwise it's a hard metal which is not ductile. It's a moderately good conductor of heat and electricity. It's very strong and cannot be shaped or rolled, but it's easily been able to rust. And everywhere you see an iron rod or iron structure, you can see that it rusts very easily when it's coming in contact with oxygen or water. Most of the iron extracted from the iron ore is converted to steel, and that is why the reason why it is converted to steel, that steel prevents it from rusting, and it can be shaped and rolled and made ductile only when it is converted into steel. So these are the major characteristics of iron. You are supposed to know 4 or 5 characteristics at least. Okay, now coming to the important part based on our syllabus, the distribution. Where is iron found in our country? Let's look at the map of iron ores in our country. You can see in Andhra Pradesh there are 2 places. In Karnataka there are 2 places. In Goa you can see two dots or pointed regions. In Odisha there's one. In Chhattisgarh there's one. In Jharkhand there's one. The most common, easiest ways to remember is most of the dominant iron or copper or manganese, all these things, the most common areas where you can find this is the best clue, will be the eastern part of India. Not the northeast, but the eastern part of India. The states like Chhattisgarh, Odisha, Jharkhand, West Bengal, Bihar, all these 5 states, the eastern part of India, it's actually called uh, where you get the Chota Nagpur Plateau, those regions. There you get so much minerals, so much metals, so much ores. It's very metalliferous region, a highly metallic region. So, and a highly mineral rich region uh, to be precise. So the eastern part of India is highly mineral rich. So you can always mark any of those states, especially Jharkhand and Odisha, for the presence of iron and the other minerals. So the leading producer is Odisha with 33%, then is Jharkhand with 27%. In Jharkhand, there's a famous place called Singhbum district, and in that Singhbum district, you have one of the biggest mines in the whole of our country. You find copper there, you find iron there, you find manganese also there. You find lot of metals and minerals in Singhbum district. Okay, Chhattisgarh, you have Durg and Bastar districts, which is also the third leading producer of iron, and the last would be Karnataka with 1,000 million ton production every year. What are the uses of iron? Manufacturing of steel and alloyed steel, nuts, weights, drain pipes, bolts. You can see the all different accessories you would have used in the curtain stands or the pipes, showers, bolts, everything which will be made from iron. The weights you see at shops, the shopkeepers, where vegetables are sold, you can see these weights. It's all made from pure iron. As supplements and tablets in small amounts, iron is also very important for our body. So very minute amounts of, for example, 1 milligram or 2 milligram iron is mixed with other additives and added as taken in as tablets also. So iron supplements and tablets are also taken in for better health. Moving into the next one, manganese. Just like iron, I want to ask you, have you ever thought that every single day of your life you are using manganese? Probably not. We don't think that we use manganese, but I think all of us use this. at homes, a battery or a cell, and we use it for clocks, we use it for maybe alarm clocks, or uh, there are other small machines or devices which runs in a maybe your TV remote. It runs in these battery. An alkaline battery is a type of a primary battery which derives its energy from the reaction of zinc metal and manganese dioxide. So manganese is being used abundantly in all of our homes. So this is the second important transition metal or the mineral which we'll be learning, and this also we use really well at our homes. Okay, just like iron, we'll also look into the ores. We'll just have two major ores for manganese. One is pyrolusite, which is manganese oxide. Manganese and oxygen, when it is combining together, it forms this ore, pyrolusite. It has 60 to 70% of manganese. Look at it, it looks dull and grayish, just like a piece of rock. It doesn't have anything unique in it. But look at the other manganese ore, it's very appealing and very beautiful. So remember that I was telling that some ores will be used as gemstones. Do you remember? This is one of that. Rhodochrosite is one very rare manganese ore which is found in sedimentary regions where you can see that. Can you see sedimentary lines? Maybe one year the one layer of the sedimentation happened, then another layer happened, then another layer happened. So when you cut it out like a piece of cake, it just you can see all the layers of sedimentation. Maybe one happened for 5 years, another happened for 2 years, and that forms this rhodochrosite, which is a very beautiful mineral, and it has 60% manganese. This happens when carbon combines with manganese. So when most of the sedimentary processes like fossils and when you have fossil fuels, this is carbon which is being dumped and layers of sedimentation take place and it is being transferred to fossil fuels. In those regions you can find rhodochrosite in sedimentary regions. Rhodochrosite can also be found in igneous regions also, but the sedimentary rhodochrosite forms these lines, and these lines are very unique to form this gemstone. Just take a look at these gemstones. It's all very beautiful mainly because of the lines that it gives and the pink color that it has. So these are the two important manganese ores. What about the characteristics of manganese? So you take pyrolusite or rhodochrosite, the pink one, and you remove the metal. This is how the metal looks like. This is how the mineral looks like. How totally different is it? Imagine the rhodochrosite look totally pink in color, and you crush it and you take manganese out of it and you melt manganese and you harden it and you make it into a single block. It looks like this. It is like no connection between the original rhodochrosite and the final product. So that's how unique our earth is and the minerals and metals in it. Okay, the chemical element manganese is classed as a transition metal. So in chemistry, you learn that a transition metal has differences in its outer shell of valence electrons, while a normal metal has a different number of valence electrons in its outer shell. You don't have to learn about that. That's more detail into chemistry, but you should know what it is. What is the meaning of transition metal? Manganese is gray, white, hard, brittle, and it can take a high polish. High polish means it looks really shiny in appearance. Compared to iron, you look at manganese and you compare it with iron, manganese is much more shiny and glossy, but it's not magnetic. The metal tarnishes or loses its lustre or sheen. Sheen or lustre is the shiny appearance, okay, as it exposes to air. So the more exposure it is having to air, it will lose its shiny appearance. Manganese occurs mainly as the mineral pyrolusite MnO2, manganese oxide, as or rhodochrosite MnCO3, manganese carbonate. So you saw both those ores, and those are the two major mineral ores for this mineral manganese. The high purity of manganese is made by electrolysis of manganese sulfate in solution. So just like how you do the blast furnace system, take out iron from the iron ores and then convert it into steel. The process you do here to take out manganese from pyrolusite or rhodochrosite, the major most important process you do is electrolysis. That is how you purify and make it 100% or 99% pure manganese. The process is electrolysis. Okay, just like iron, the distribution is there's a lot of places where you find manganese, but the most important places of manganese we'll be looking right here. Manganese distribution is always associated with iron ore areas. Odisha, just like iron, is the leading producer or leading in reserves, which means it has the most amount of manganese present under the surface. When you look at the whole of India, that is reserve. It has more under the surface. But when you look at how much manganese is being produced, not how much ore that the state has, how much is being produced, how much industries and factories are built to convert that ore into manganese. When you look at that, Maharashtra is leading. But when you look at what is inside the surface, how much ores that the state has, then Odisha is leading. So you can look at the districts, Keonjhar and Mayurbhanj in Odisha, Nagpur and Bandara in Maharashtra, while Visakhapatnam in Andhra Pradesh also has manganese. Karnataka, Shivamogga district also is known for its production of manganese. What about the uses? Manganese is an essential element in photosynthesis. Without it, there would be no free oxygen on Earth. Wow, we didn't know that. Every time we take an oxygen, do we remember that it is manganese also has a role to play in it? No, but manganese has a huge role to play in photosynthesis when the plants release oxygen. Used as a black bond pigment and also a filler in dry cell batteries which we use every day at homes. So that's also made out of manganese. Most manganese ore ends up in steel production. When iron is converted into steel, if you remember the blast furnace process, at the end manganese is actually put into it. If you go and see the previous video or just go through the previous chapter, you can actually find out that manganese is added into it to make it more stronger. So manganese is an additive which actually desulfurizes, which removes the sulfur content, which removes the oxygen content, that is desulfurizing and deoxidizing, means removing sulfur content and removing oxygen content from iron and making sure that it makes strong steel. So steel bars, steel pipes, manganese has a role to play. To produce a variety of alloys, example aluminium, it is used in soft drink cans. Most of you would have had soft drink cans like this Coke tin. And high pressure soft drink is inside. But at the same time, the high pressure soft drink should not break the tin outside. So it is made out of manganese. Manganese, it's actually made out of aluminium, but 1% of manganese is added to the tin to make sure that it is stiff and there's no corrosion, there's no resistance because its liquid content is inside. It must not start to rust and corrode. It will be bad for health. To make it non-corrosive and to make it stiff, to resist the pressure exerted by the carbonated juice inside, manganese is added to the cans. It's also widely used in paint industry. So these are multiple uses of manganese. Okay. Number three, bauxite. Bauxite in our everyday life, you'll be really shocked to know that among all the four, the most relatable thing as a student for you or you see every day in school, you see bauxite, the use of bauxite every day in school. Yes, aluminium foil. Every single day when you come to school, you would see many of your classmates or many other students in school using this or wrapping their food in this, or you would have seen this in your home also. This is actually aluminium and bauxite is an ore taken from which aluminium is made. Characteristics: bauxite is an ore of aluminium, aluminium oxide. So look at this picture. Imagine this piece of aluminium ore being converted into that aluminium foil or the sheet. So the picture you saw before, the aluminium foil, and the picture of this rock, it's totally unrelated, but it's true that that foil is made from this rock. Soft material with a hardness of only 1 to 3 on Mohs scale. Mohs scale of hardness is a scale like how you have a Richter scale for earthquake and an intensity you have Mercalli scale. So Mohs scale is a scale geologists use to understand the hardness of rock. So among the Mohs scale, there's 1 to 10. 10 is the hardest, 1 is the lowest. It is just having only 1 to 3. So it's very light. You can break it very easily. So this material is much lighter. And it has a low specific gravity, which means it is not much heavier. It is very light when you hold it in your hand. Of all the metals, only iron is used more than aluminium. So iron is used in most of the industries, for machines, for all the infrastructure. But after iron, the most commonly used metal in the whole world and in our country is aluminium. For producing aluminium, we actually crush bauxite and purify it using Bayer's process. You don't have to know what's the detail of Bayer's process. You just have to know that it has been crushed, and the process that helps us to change bauxite to aluminium is Bayer's process. So blast furnace helps in converting iron ore to iron, and then we learned for manganese there's also a particular process, and for bauxite also. So just remember the name of the process alone, or what is the main method which is used to convert the ore to the metal. India has a large bauxite reserve for about 25,000 or 2500 lakh, sorry, that's a mistake from my side, 2500 lakh tons. There shouldn't be a comma after 25. So it's actually 2500 or 2500 lakh tons of bauxite reserves are actually found in our country. India is the fifth largest producer of bauxite in the world, and we use aluminium every single day. There's so much, not just the foil, we use aluminium in many more ways. We'll be looking about that in the uses. Distribution, there's so many places where bauxite is found. You can see the eastern regions again dominant in production of bauxite and aluminium. Odisha has so many places, Jharkhand has some places, Chhattisgarh has some places, Andhra Pradesh has some places. But surprisingly, the western region also has some places in bauxite. While you look at the other minerals, the western region won't have. Gujarat and Maharashtra won't have much reserves, but western region has much reserves in bauxite. Main states producing bauxite are Madhya Pradesh, Jharkhand, Gujarat, Maharashtra. Madhya Pradesh, the Amarkantak Plateau and the Balaghat district. Chhattisgarh, Bilaspur and Michael Hills. Jharkhand, Ranchi and Plamau districts, and Gujarat, Jamnagar and Kheda. So these are the major places. You can know the name of the district and the name of the state. You should know at least two places, especially the leading producer. You must know the leading producer of each and every mineral. If you learn four important metallic minerals, you should know the leading producer of all the four metallic minerals in our country. Uses, just like I said, bauxite, which means the ore of aluminium. So we'll be discussing the uses of aluminium. As a result of low density, low cost, low corrosion resistance, aluminium is widely used around the world. It has endless benefits. Unlike some metals, aluminium has no aroma. It has no smell. Hence, it is widespread used in food packing and cooking pots. So just like uh, steel, more commonly than steel, aluminium is used. But it is advised that stainless steel pots are used, should be used than aluminium, because aluminium has a tend to break and rip apart when you're cooking at high temperature, and that can mix with your food and enter your body and can cause harm. So if you're using aluminium at home, it is preferred and advised that you switch to stainless steel vessels. Although not quite as good as silver and copper, aluminium is still an excellent conductor. It also is cheaper and lighter than metals, so it can be widely used as overhead power lines. You would have seen these kind of power lines in front of your home in important cities. When you travel in the roads, every important power line is made out of aluminium. All the spare parts of automobiles made of aluminium. So you have go to any mechanic workshop, or you have any spare parts at home for your vehicle, everything would be, or most of the things would be made out of aluminium. Since it's lightweight containers, it's a very important point. Lightweight containers can be made that doesn't add on to the weight of what it holds. Imagine you have a container, the container itself is very heavy. You put something in it, totally it will become much more heavy. But look at this aluminum container. Have you held this container in your hand? It's so light. But can you believe that it's made out of a metal? So that's a very big advantage of aluminum. It's extremely light when it's so thin. When it is made into a sheet, it's so light we won't even be able to believe that it's metal. So this aluminum sheet does not have any weight, but at the same time it doesn't have any leak. It holds, and it can hold on weight to a very good level. So it doesn't add on to the weight if it's made into a container. The last metal we'll be discussing is copper. Copper in our everyday life, and I think among all the four, the most diversely used. Diversely used means we just don't use it in one area; we use it in different areas. That is what I want to mean by diversely used. Among all the four we discussed so far, will definitely be copper. And you can start looking at it. Copper cables, all your electricity can never work properly without copper cables. Then this is the IC chip or integrated circuit, and this integrated circuit is required for a laptop, for a smartphone, for any electronic device. And today in the day and age, electronic device is very important. You are right now learning this chapter about copper because you have an electronic device, and that electronic device runs because of its circuit, and the circuit board is made out of copper. So without copper you will not be able to learn about copper. That's how important copper is. Okay, so smartphones, just like everybody has smartphones today, and smartphones, the most important aspect of a phone is its circuit board, and the circuit board is made out of copper. Major copper ores, there are so many copper ores actually, but I'll be just giving two copper ores. One is chalcopyrite, and this chalcopyrite is actually called fool's gold. It's called fool's gold because people who don't know to find out real gold will actually be fooled to think that this is gold, but it is not gold. It just appears to look like gold, and it can fool people who do mining that it can look like gold. So that's a very interesting factor about chalcopyrite. It is actually copper element which is combining with sulfur. So when copper and sulfur combines together, you get copper sulfide, and it has a little bit of iron also. Then you have another beautiful ore which is called malachite. Just like rhodochrosite, malachite can also be made into a gemstone. So you can look at that, how malachite is beautifully shaped and polished into a gemstone. So malachite is copper carbonate, where you have carbon, where you have also have hydrogen, you have oxygen, but dominant elements are copper and carbon. Where in chalcopyrite, the dominant elements are copper and sulfur. Chalcopyrite will give you 35% of copper, while malachite will give you 60 to 70% of copper. Actually, in the prehistoric times, in Egyptian times or the old civilization, those times copper was starting to be smelted, and it was starting to be used as a weapon. If you remember, you learn in history and stuff like that. So those areas where you find these Egypt or Mesopotamia or all these prehistoric civilization areas, this malachite ore is very, very common there. And what they do is they crush this malachite and just melt it. At one particular temperature, it starts to produce.
Have you ever wondered what your life would be like without copper? Don't worry, it's not something most people spend a lot of time thinking about. But the fact is that without this basic element, you'd be stuck with no running water, no phone, no computer, and no electricity for that matter. In other words, without copper, your life would be downright primitive. So now that you know how important copper is, let's talk about how it's made. Or to be more accurate, let's talk about how it goes from this, a basic element mixed in with a bunch of other minerals and garden variety rock, to this, 99.99% pure copper cathodes manufacturers use to make that long list of stuff you depend on every day. The whole process starts with monster machines and high explosives. At the Bingham Canyon mine, teams of blasting experts drill 12-inch diameter holes 56 feet into solid rock, fill the holes with about 1,200 pounds of high explosives, and boom! Solid rock instantly becomes loose rock. In fact, every single day, blasting crews drill and blast about 160 of these holes to create 500,000 tons of new blasted ore. So exactly how much is 500,000 tons? Well, a humpback whale, one of the world's largest animals, weighs about 50 tons, which means you'd need about 10,000 of them to balance the scales. So how does Kennecott deal with this nearly inconceivable volume of blasted rock? Well, the simple answer is that you pick it up with giant shovels that can carry 100 tons in a single scoop and dump it into massive haulers. These trucks are capable of hauling 320 tons, or about 6 whales, and are about the same size as an average 2-story house. These huge hauling machines carry the blasted rock, which contains minerals called ore, out of the mine and drop it into one of the world's largest rock crushers. This giant crusher turns the big car-sized chunks of loose ore into more manageable, basketball-sized rocks at the rate of about 10,000 tons per hour, and then drops the crushed ore onto a conveyor belt. The conveyor system, which is basically a giant moving sidewalk for rocks, carries the ore through a 3-mile tunnel, then continues up hills, down hills, and past 6 transfer stations until it reaches the Kennecott grinding facility. This 5-mile trip takes about 29 minutes. If only rocks could appreciate the fun of traveling 5 miles on a moving sidewalk. When it reaches the grinding facility, the ore runs through a series of giant rotating mills. This grinds the basketball-sized rocks into a fine powder. After all that blasting, hauling, crushing, conveying, and grinding, the copper is finally ready to be separated from all the other minerals and materials that surround it. This is also where the process switches from brute force to applied chemistry. The finely ground ore is poured into flotation cells and mixed with exactly the right amounts of water, air, and chemicals. This causes all of the copper-bearing minerals to cling to air bubbles and take a free ride to the top of the flotation cell. The result is a liquid material called copper concentrate, which is now about 28% pure copper. This concentrate is pumped 17 miles through a long pipe to a filtering facility and dumped into a big storage tank. At the filtering plant, the concentrate is pressed, filtered, and dried in a massive rotating dryer. After it's done, the material looks a lot like coffee grounds. This powder goes into a large, very hot flash furnace, which causes the dried concentrate to melt and turn into a molten metal called matte copper. During this process, sulfur gases burn off and are then captured and cleaned. A combination of iron and silica rises to the top, and the heavier copper matte sinks to the bottom. This matte, which is now about 70% pure copper, is collected, cooled, and sent through yet another series of furnaces. This burns off most of the remaining impurities and leaves us with molten copper that's about 99% pure. This nearly pure copper is poured into 700-pound copper plates called anodes and left to cool. 99% pure copper is good, but getting to 99.99% takes a little extra molecular mojo. The anodes are shipped to a final tank house facility, where they're sandwiched between stainless steel plates and loaded into big square tanks that are designed to conduct electricity. The tanks are filled with an electrolytic solution that creates positive and negative electrical currents, just like the world's biggest car battery. This current causes the pure copper ions to jump to the stainless steel plates. It's a pretty strong attraction. The result is a 99.99% pure copper cathode. These cathodes are stripped away from the stainless steel plates, corrugated, strapped together into 5,000-pound bundles, and whisked away to their final destinations. And finally, they're turned into cell phones, computer components, copper pipes, copper wire, and many other things that make our modern lives possible. That's the amazing story of how we take copper from this to this. 99.99% pure copper. It's not easy, but when you stop and think about what our lives would be like without copper, it's worth it.
So that video took us through a great ride to show how copper from any copper ore changes from 28%, 30%, 50, 60, 80 to make sure that it's not even 90 but 99.99%. And it's a lot of hard work, but that's what makes our life easier. That hard work of converting copper ores into copper, and 99.99% copper to that extent makes it much more easier for manufacturing goods and any other devices which needs copper. Okay, looking and finally going through the characteristics and uses. So we have copper characteristics. The word copper and the symbol Cu is derived from the Latin word cuprum, which means the metal of cypress or cypress, You can pronounce it like that also. Between the Mediterranean Sea. So if you look into geographically in Europe, you can see Italy and Greece and all those places. So in the Mediterranean Sea, next to Italy and Greece, you can see a small island called Cyprus. In the island was the first ever copper mine. So for the first time, copper was, after civilization took place, mined. Copper was first mined over there, and that is how that place's name was fallen for the metal, and the metal was named after the place, and even the element's name Cu, or the symbol, is from that place. Just like manganese, also copper is classified as a transition metal. Of all the metals, copper is one of the most likely to be found in its native state. It's also found as copper oxides and copper sulfides among ores. So it's a very important point. Some elements, I told, it doesn't have to combine with another element. It can occur as itself and still be called a mineral, right? And I gave the example of graphite. Copper is a metal, but still carbon was not a metal when I told about graphite, but copper is a metal. Mostly metals don't occur alone. Metals need some combination to occur. But copper is actually one of the very few metals that can occur in native form. So you can see the three pictures. The native copper, it doesn't combine with anything. Copper sulfide doesn't look like copper. No. Copper oxide doesn't look like copper. The previous picture we learned about malachite copper carbonate, it was green in color. So among all of this, only native copper looks really like copper because it is 100% pure copper. It can actually straight away be purified and directly start. You can change it to copper cathodes and start manufacturing stuff with it. You don't have to do all the whole long video process which we saw when it is native copper. So copper is one of the very rare metals which occurs in native form without connecting with any other elements, but it also occurs as sulfides and oxides and carbonates. Copper is reddish orange soft metal that takes a bright metallic luster. It is malleable, ductile, and an excellent conductor of heat and electricity. Only silver has a higher electrical conductivity than copper. So copper conducts electricity very well. At the same time, it's high. It has a high melting point. It doesn't melt, so it can resist heat also. So all those double triple benefits are there with copper. When exposed to air, gradually it starts to tarnish or it starts to become dull and brownish in color. So even in the native copper picture, you can see some parts are little dull and brownish, but some parts are little shiny and glossy. That's because in the parts which are more exposed to air starts to become dull. If exposed to air gradually, yeah, I think that was a mistake. The same point has been explained again. Okay, the distribution of copper, just like everything else, you can look at the map, and this is mostly found in the region of Rajasthan, and also again the eastern parts are again coming back. You have Jharkhand, you have Bihar, but Rajasthan is one dominating place where you find copper. So Singhbhum district, Jharkhand, is where you find copper. Malanjkhand belt of Balaghat district in Madhya Pradesh, we learned about the same place in another mineral also, which is the largest producer of copper in India. And there are many places. You can look at the picture in Rajasthan. I've just written three places: Alwar, Ajmer, and Chittorgarh in Rajasthan are three important places. There are other places too. If you want to learn other names, which is easier for you to remember, you can learn that, or other places in Rajasthan which has good copper presence. The last slide of this class, copper uses. We know that we have seen a video and we see that it has a huge list of benefits and uses, and we'll just be discussing a few. Because of its excellent conductivity, copper is the most commonly used as electrical wires for wiring and motors. Because it corrodes slowly, copper is used for it's used for roofing, guttering, and rain spouts in buildings. So to build gutters, to cover your houses as roofs, it's still used in plumbing and cookware. Utensils like these are very common nowadays, copper utensils. Commercially important alloys. Alloys are a combination of metals. Copper and zinc will give you brass. Copper and tin will give you bronze. All those are made from copper. This is a picture of an algae being dominating over a water body. So copper sulfate is being used as fungicide or algicide in rivers to take away algae and take away fungi. And in lakes and ponds where algae and fungi are covering and affecting the organisms, it can be used like that. In heating systems, due to its high melting point, so not just good conductivity of electricity, high melting point, it needs to have extremely high temperature for copper to start melting. So it makes sure that it can heat something without melting the metal itself. So copper coils inside water heaters or other heating materials, you can find most of the coils will be made out of copper because of its high melting point. So that's it. I hope you were able to learn about the four important metals. You learned about minerals, about ores and rocks, and the relationship it has with all these four important metals. And copper, aluminium, manganese, and iron are broadly and importantly used in our homes. So I hope this lesson was beneficial and useful for you, not just for your studies but for your future as well. See you in the next class.